in general, if you're finding an inverse, there's a couple different ways this can look depending on if you have a graph, if you have a table, if you have an equation. All right, so I'm going to start and write out what to do if you have an equation, which that's going to mostly be on the back of the notes today. So if you have an equation, first thing I'm going to recommend, if you have function notation and you have an f of x, what I would tell you to do is replace the f of x with a y. It'll just, I promise it'll just make it easier to look at when you're trying to find the inverse, but you want to just, if you have f of x, if you have function notation, just replace that notation with y, and then what you do is you switch x and y, and then you solve for y, which just means you're going to get y by itself on one side. So if you have function notation, we're just going to replace f of x with y. Then you're going to take the equation, you're going to switch x and y places wherever they're at in the equation, and then you're going to get y by itself on one side or solve for y. Now, a little different thing, if you have a graph or a table, which those are the first two we're going to do actually here on the front. If you have a graph or a table, you are literally just going to switch x and y coordinates. So if the original gives you an x value, it'll be the y coordinate in the inverse, and vice versa. So basically, like let's say in my original I had the point xy, the inverse would have the point yx. We're just literally going to trade places. So similar concept, but it might look a little bit different as you actually go through the problem. Okay. So what I'm going to do first is work with tables and graphs with you guys on the front, and then on the back we'll actually work with some equations. So let me scooch this guy up here a little bit. Okay, so I just have a list of x values, list of y values in a table. So to do the domain, just a little review from earlier in the unit. Domain, you literally just list the x values. Now, if you have points, you don't have a graph, you can't see that these are connected or anything like that. We don't want to do an interval. We just want to actually list the points. And the notation for that, it's called a brace. It just looks like a little squiggly line. I'm not going to be picky about that or anything. But you're just going to list the x values, and they do not have to come in a particular order. I'm just listing them how they appear in that table there. To do your range, all you got to do is list your y values. So I'm just going to do 3, 5, 7, 9. If any of them repeat, which they don't here, you don't need to write it twice. Okay, now this is literally all you have to do. If you're doing a domain of original and you want the inverse, you're just going to write it as the range or the y values of the inverse. So I'm literally just going to copy this order right here, -4, -2, 0, 2. And the domain of the original should be the range of the inverse. So the -4, -2, 0, and 2 are now going to be my range. They literally just trade places. That's all you have to do for an inverse. Same thing, the range or the y values of the original become the domain or the x values of the inverse. You just got to make sure you match them up with the same values as the original table. So like the -4 goes with the 3. The -2 goes with the 5, and on down the table. Just make sure you keep them in the same order so the points still go together. And just trading x and y. And the same thing here. The range of the original should be the domain of the inverse. And so I can just copy that right down. So this trades here, this trades here. So you literally don't, I mean, if you knew the domain and range of an inverse, or sorry, if you knew a domain and a range, you could find the inverse literally just by switching them. You wouldn't even need a graph or a set of points or anything. So that's all you have to do is trading places. Now, I do want to show you what the actual notation for an inverse looks like just real quick, because you'll probably see this as you go through some of the questions. So let's say my original, or like whatever you're given as your equation or your function to start with would be just f of x. And then the notation for the inverse, it kind of looks like a -1 power. It looks like f and I read this as f inverse of x, but it almost looks like a little -1 power. It is not a -1 power. It is the notation for any kind of an inverse. There are buttons for this on the calculator. It's not going to do an equation for you, but you would see a -1. It's used for other things, but that is notation for an inverse. It's not a -1 exponent. Okay, is anybody having a question? Okay, so we're going to do a graph here first. So we're going to graph the inverse, but first I'm going to ask you some questions about just the graph that's already there. And then I have the notation here. We don't have to write an equation here. We'll do that on the back. But this just says f of x, so the graph I've got here, and then we're going to do the domain and range of the inverse after we get it on the graph here. So what would you guys tell me for the domain, just the original graph that's on the picture as it's on the paper there? What would you put for your domain? Perfect. Okay. Now, can we tell me the range for that same? Yeah. So close. 1. Okay, yeah, so come from the bottom to the top. This is the first point you would touch, would actually be the vertex here. You want the y coordinate, which is 1. And we're going to go ahead and put a bracket on that because I actually touched that point, and then it goes up forever, so infinity. Okay, now here's the deal. If I have a graph, probably the easiest thing for me to tell you to do would be just grab a couple points that go right through a corner, especially like if you don't have a table. And I'm just going to actually, let me just jot down these points. I just kind of went right through a corner to get. So one of them is -6, 9. I have the point -4, 3, -2, 1. I just grabbed 5 points. 0, 3, and 2, 9. Okay, so that's my original graph. I literally just grab points off the graph. To do the inverse, you're just going to trade x and y. So my inverse, if I just switch these around, would have the point 9, -6, 3, -4, 1, -2. I'm not changing any negatives or anything like that. We're literally just switching the x and y values places. 3, 0, and 9, 2. Now, if you kind of plot these points, you kind of see the shape that it'll take. It's the same shape, but it's going to be going in a different direction. So this is a quadratic here, right? This is a parabola. And what we're going to graph, you should see it. It should be like a sideways parabola when you start plotting these points. So let's see. If I do like 9, -6, I've got 3, -4, 1, -2. Okay, so I literally just traded the x and y coordinates. Now this is still the shape of a parabola, but it's going sideways. And that would be my inverse. Okay, now I just want to write a little tiny note for you guys here. The inverse for any graph is a reflection over the line y equals x. And I'm just going to plot y equals x in mx plus b form. Its y-intercept is 0. The slope would be 1. It would just start right at the origin, just go up 1 over 1. Literally, it's a perfect diagonal right through the first and third quadrants of this graph. I don't think I did a very good job drawing that. That looks a little sketchy. But anyway, the idea is, though, if I were to literally cut this out on a piece of paper, if I were to fold it in half on that diagonal, if I had done a good job drawing this, these would match up. So they're a reflection over each other over the line y equals x. So like the vertex here and the vertex, the same distance from that line. You don't have to measure it or anything like that, but it should be a reflection over the line y equals x. Now, if you guys look at our inverse that we just did, if what I told you at the top was true, the domain and range should just switch, right? So if you do the domain for this graph that I have in red on my paper, you don't start touching any part of that graph till you get to this point right here, which has an x-coordinate of 1. And then it goes to the right forever. So it'd be 1 to infinity, which is the range of the original. So they should just be in exact reverse of each other. And I know this doesn't always look like it, but for your y values or for your range for the inverse, this part would go down forever. It just goes kind of slowly. This would go up forever, so you would cover every y value negative infinity to infinity, which is a switch. It was the domain of the original, so it's the range of the inverse. Is anybody having a question about the tables or the graphs? Okay, we'll do equations on the back. Now, do me one favor real quick, just because I don't want to mess around with fractions. Can you, where I have the very last example up here at the top, will you change that -3 to be a -8 just real quick for me? And then we're just going to find the inverse of each of these algebraically. So each one gave you an equation. They were originally written in function notation. What I wrote underneath was just to interchange the f of x, and I replaced that with a y. The only reason I'm doing that is just so it's a little bit easier to work with when you're not messing around with parentheses and the f of x and stuff like that. It's just a little bit easier usually for people to do. So what I'm going to do is I'm going to switch x and y. So I'm just going to recopy this, and I'm going to switch x and y. So instead of y equals, I'm going to write x equals, and then in parentheses, I'm going to write y minus 4 squared plus 5. Okay, so I'm just going to switch x and y. Everything else stays where it's at. And then what you want to do to actually write the equation of the inverse is get y alone on one side. So if I was trying to get y by itself, what might you do there first? Move the 5. Get rid of any addition or subtraction first, right? All right, so I'm just going to move that 5. And I can't actually combine that with the x, so it would just stay x minus 5. All right. Now, do I want to FOIL? No, you can. Don't. Okay. What should I do next? Oh, people are like whispering it. Square root, don't FOIL. Okay, do not FOIL. You're just going to make more work for yourself. What you actually want to do is take a square root. Okay, now here's the situation. If I introduce a square root into the problem, which I did there as I was solving that, you do need to put that plus and minus symbol in front of it. So we're not actually taking any square roots. We're just going to leave this written out, but I do need the plus and minus symbol in front of that. Left on the other side, the square root and squared cancel each other out, so you would just have y minus 4. The only other thing you got to do is get y alone, so I would add 4. Now, that does not go into the square root. Don't add that to the -5. That's going to stay outside. And I'm going to write the y on the left, just because that's what I'm used to. It would be y equals plus or minus. X minus 5 would be under the square root, and then the plus 4 would be on the outside. The original problem is a quadratic. It's just a parabola in vertex form. This, we haven't done these yet, but this is actually a square root, and it's going to be the format we'll graph in our next unit when we get into radicals. But the square root is actually the inverse of a squared when you do the equation. So this is a square root. All right, so this next one I have is a square root. So when I go backwards, the inverse should be a quadratic. Okay, and I'm going to start going through this here real quick with you. So this says f of x. I interchange that with a y just to make it easier to work with. And to do an inverse, once you got your equation, just switch x and y. And then to get the actual inverse equation, you want to get y by itself on one side, or solve for y is how we would probably word that. What would I do first there? What do we think? So 5, yes. Let's move the 10, okay? Just add 10. All right, you can't actually add that to x in terms of simplifying anything, so it would just look like x plus 10. All right, how am I going to get rid? You cannot subtract the 7 out from underneath that square root. So how do I get rid of square root? Okay, square. Now, here's the deal. If you guys, and I didn't really make a whatever about this, but I'm going to square both sides. I did write up here in the directions. Just go ahead and leave that as a factor. Don't FOIL that out. All right, it just says don't FOIL it there. Don't FOIL this. Now, the square root and squared cancel each other out. So you get x plus 10 squared. Don't FOIL, just leave it alone. Y plus 7. The only other thing you're going to do there real quick is just move the 7 to get y alone by subtracting it. Again, it doesn't go into the parentheses with the 10 or anything like that. It's just going to go to the side. So I'm going to write y on the left here. It would be x plus 10 squared minus 7. And that's just leaving that, if we were to graph that, that's just a parabola in vertex form, if you remember that from first semester. So like my vertex would be negative 10, negative 7, and we could do our 1, 3, 5 pattern if we were graphing it. But that's why just go ahead and leave it in the factored form in case you're asked to graph it, and that way you don't have to multiply it all out. All right, so square root and squared are inverses of each other. The last one is just the equation of a line. What? Does anybody know what the inverse of a line would look like?
Isn't it like opposite of the
Yeah, it's gonna. It'll just be another line, but yeah, the slopes are gonna be. They're not necessarily. I'm trying to remember now. I don't think they're opposites, but I do think they're reciprocal. They're gonna have reciprocal slopes. Okay, so they're gonna be an inverse. When you graph a line, its inverse is just going to be another line. The slopes are going to be flipped over is what you're going to see when we do this. Okay, so this one, again, just change x and y. So I'm going to write x equals 4/5 y, and then I had you guys change that real quick to -8 just so I didn't have to mess around with the fraction. Okay, same thing. Get rid of any addition or subtraction first. So for this, I would just add 8. So it'd just be x plus 8. And then how would you get rid of the 4/5 and that's attached to the y there? And there's a couple different ways you could do it. Elliot, what do you think? Yes. Okay, so if you just want to do the reciprocal, you could do it all at once. Or if you want to do multiply everything by 5 and then divide everything by 4, you can do it that way too. I'll just go ahead and do 5/4. So with the x, go ahead and just don't write like 1.25 or anything. Just 5/4 x. Okay, 5/4 times 8. You're going to do the numerator times the number, which would be 5 times 8, so 40. Divide by the denominator or use your calculator. But this is just going to end up being 40 divided by 4, so it'll be 10. And then if it's me, I just, for some compulsive reason, need to write the y on the left side. So I'm just going to do that. But it's just going to be another line if you're doing the inverse of a line. Okay, is anybody having a question? No, they're not, because they're not gonna. They don't have to intersect each other at a 90-degree angle. So they're not going to be perpendicular to each other. They're just a reflection of each other over the line y equals x. So it should just, the slope should just be the reciprocal. But you can see the y-intercept's totally different. All right. Now, we did this a little bit yesterday, but I did not give you this definition or call this yesterday. This was that last example where we got x when we simplified the composition for both. This just says if you have inverses, f inverse of x, if you compose them like we did yesterday, f of f inverse of x, or if you reverse that order, f inverse and then f of x, no matter what, if they're inverses, both of those will simplify to be just x. So I'm going to show you how this works, and this is kind of like a proof, like you're not writing out steps like you would have in geometry for a proof, but you're just doing an algebraic proof for inverses in this question here. So I give you the function. It's 2x plus 8. So I'm just going to rewrite that really quick as y equals 2x plus 8 to make it a little bit easier for me to do the algebra to find the inverse. Okay, now all you got to do to find the inverse, this says find f inverse of x. So I'm just going to switch x and y real quick. Everything else is going to stay the same. But we want to get y by itself on one side. So all I would do, let's move the 8. I'm just going to subtract it real quick. So I'd have x minus 8 equals 2y. And then I got to divide everybody by 2. Now, in terms of writing this, I'm going to go ahead and write y on the left side there. Now, if I have x over 2, would you guys be okay with me saying this is like 1x over 2? This would be 1/2 x if I kind of wanted to pull that slope to the side. And then negative 8 divided by 2 is negative 4. So that would be my inverse. All right, I'm just going to write, and you don't rewrite this, I'm just going to rewrite it real quick. So f of x was the 2x plus 8, and the inverse, we just solved for that real quick, was 1/2 x minus 4. Okay, now I'm going to prove that these are inverses by doing composition, what we did yesterday, to show that if I compose these with each other either direction, that I get x as my answer. All right, so bless you. For the first one, this says f of f inverse of x. So for this first one, what you want to do is you want to grab the inverse, and we're going to plug that in for x into the f of x function, right? You have to show that this works both ways. So this is the function composed with its inverse. So I would do 2, and then instead of x, you just do that 1/2 x minus 4, and then plus 8. And then we're just going to simplify. So if I take 2 times 1/2, that would just be 1x, and then 2 times -4 would be -8, and then I have that plus 8 on the outside. The 8's cancel each other out, and you get x. That's all you have to do. Okay, you do have to prove it works both directions, though. So the other direction, this is the inverse composed with the function. So I'm going to take the original, and I'm going to plug that in everywhere I see an x to do this second one. All right, so I'd have to see both. They're going to look similar, but you're going to see different algebra here. So the inverse is what I'm going to plug into now. So 1/2, and then f of x goes 2x plus 8 in place of the x there, and then minus 4. And again, it's just 2 steps. It'll look similar, but it's going to be a little bit different than what the question we just looked at. So half of 2 is just 1x again. Half of 8 is positive 4, and then you have that -4 on the outside. The 4 and -4 cancel each other out, and you're just going to get x. Does anybody have any questions? Okay, I'm going to have you compose inverses in this last example just real quick with numbers here. Okay, so just so you don't rewrite this, is just so you can see it on the screen. So f of x, I'm going to use the functions from example right above here, just so you guys can see them on the screen. Okay, so my first question says f inverse composed with f of 12. If you all like that parenthesis notation a little bit better, it would look like that. But basically the one closer to the number or the one on the inside goes first. So first thing I got to figure out is, what is f of 12? All right, so the f of x function was 2x plus 8. So 2 times 12 would be 24 plus 8, bless you, that would be 32. All right, so I'm going to take 32 to get my final answer and plug that into the inverse. So the inverse with the 32 plugged in would be, let's see, half of 32 would be 16 minus 4 would be 12. So that's my actual answer, would be 12 if I compose those two. Okay, now I don't want you to write anything down or do any math. Tell me the answer to the next question. -24. Yep, anytime you, I just proved it to you right here. Anytime you compose a function and its inverse, they cancel each other out. I could literally put a picture of a dog in there and that would be the answer, okay? So this is just -24, this is a, totally doesn't matter the order. You can put anything, when you compose a function and its inverse, they cancel each other out. You don't have to do the math if you understand that. I just proved it to you with the first one. But they cancel each other out, and it should just give you back whatever is in that set of parentheses. Okay. Does anybody have any question? Okay, I'm going to let you guys work on the homework. Let me say one thing to you about just a couple questions, just really quick, because I had a lot of questions last period. If you're looking at the page, this is the back of the page of the 6-4 homework. You don't need to rationalize any denominators or anything like that. So when you find the inverse, number 6, you should have like a fraction under a square root. I don't want to, like, I want to have you guys try to do the problem, but for number 6, you should have a fraction under a square root. So don't think you're doing something wrong there. I had some people asking me about that. And then what was the other one? I can't remember. It's number 6. You should have a fraction, but the whole thing should be under a square root. And if you have fractions, you don't need to, you can just leave them in fraction form if you want to as you do the problems. A couple of these look just a little bit different algebraically when you do them than the ones I had on the notes. So I can't remember what the other problem was. Maybe it was just that one. But for sure, number 6 is going to have a fraction under a square root. I'll just answer questions if you guys have them. I just remember a lot of people were asking me about that last period. All right, I'm going to shut up so you guys can work. We still got about 10 minutes here. So please let me know if you have a question. I will be